We'll start this lesson off by defining what exactly is Hyper-V Replica. This new feature of Windows Server 2012 is a built-in software-based asynchronous replication mechanism. In other words, it will replicate your virtual machines from one site to another site. For example, one data center to another data center over a wide area network link, such as a private link or even a secure VPN tunnel through the internet. Hyper-V Replica was designed for small to medium enterprises and small to medium-sized businesses who need lower priority replication of virtual machine traffic for disaster recovery purposes. It works over limited bandwidth, wide area network links, but it's not designed for those large enterprises. It's not designed to replicate a very large number of virtual machines like you would have with hardware-based SAN replication. So it doesn't replace those high-end CDP or continuous data protection solutions like those found with hardware-based SAN replication. Hyper-V Replica is built into the Windows Server 2012 operating system, and again, it's designed for the SMB that just needs to replicate a smaller number of Hyper-V virtual machines from one data center to another. It works by creating a host replica log, or an HRL, on the Windows Server 2012 Hyper-V host that's running the primary virtual machines that need to be replicated. That HRL log is then replayed to the replica host, that's the backup host, across the wide area network link, ideally every 5 minutes, to recover the virtual machines if needed. In other words, the recovery point objective, or RPO, for Hyper-V Replica is every 5 minutes. The replay is done in reverse order so that the latest writes are written first. In other words, on the replica host or the backup host that's going to provide the recovery of the virtual machine, the latest changes to the virtual machine are applied first. There is no automatic failover. In other words, if the primary host goes down, the replica host isn't going to just take over for that primary host. So there is no automatic failover, which means that the RTO, or the recovery time objective, is totally up to you and it's totally manual. So it's not a high availability solution such that the primary goes down, the backup just immediately takes over. It doesn't work like that, but it's still extremely useful for many companies out there. So how do you use Hyper-V Replica? Well, let me show you. What you'll do is configure replication on each of the virtual machines. That means one at a time. You can't just say protect everything. You need to configure it per virtual machine. You'll have to configure authentication, either HTTP, Kerberos, within the Active Directory Forest, or HTTPS, which is destination SSL certificate based, for the interforest, or for hosted replication. And that's because some companies out there are providing hosted replication, in other words, disaster recovery as a service, using Windows Server 2012 Hyper-V Replica. What you'll do is you'll select the virtual machine disk that you want to replicate. You'll select the destination host. You'll select the compression data transfer. Optionally, you can enable VSS once per hour. That's the volume shadow services, so that these would be application-aware replications. In other words, the state of the application is paused while the replication takes place to ensure that no transactions are lost. You'll configure the number of replicas to retain on the destination, and then you'll choose the initial replication method, which could be LAN. You could do it over the network. You could do it offline, let's say using a removable USB drive. You could take that to the replica host to perform the initial replication, or you could use a seed virtual machine. So I'll be covering all these things in detail, step by step, in the demonstration. So with that, let's get started. Here in our Windows 2012 Hyper-V lab, to configure Hyper-V Replica, or replication, I've added our second Hyper-V host here, which is also in the same data center in the same lab for demonstration purposes. Of course, normally that second Hyper-V host would be on the other side of a wide area network or a secure internet VPN tunnel. Hyper-V Replica is configured per virtual machine. It's not something you configure on, let's say, an entire data center or an entire Hyper-V host or a group of virtual machines. It's configured one virtual machine at a time. So to configure Hyper-V replication, you can either right-click on the virtual machine and go down to Enable Replication, or you could go over here to the Actions panel, and I could click on Enable Replication since I've selected the virtual machine already. This brings up the Enable Replication wizard for this particular virtual machine. In this case, it's called Win 2012-1. So this wizard is going to guide us through the process of enabling replication. I'll click Next here. And the first thing we need to do is to specify which Hyper-V host will receive the replication data for this virtual machine. In other words, which Hyper-V host is going to take over and run this Hyper-V virtual machine should the host that it's running on right now go down or be unavailable for some reason. In our case, the Replica server is going to be our secondary server or our failover Hyper-V server called Hyper-V2 or HV2. I'll click Next here. So it verifies the configuration of host Hyper-V2, and it tells us the Replica server that we specified is not configured to receive replication from this server. What that means is we haven't enabled or allowed replication on host Hyper-V2. Now, we don't have to do that on the server that's sending the virtual machine replication data. We only have to do it on the server that's receiving the virtual machine replication data. And it gives us a nice button here to configure host Hyper-V2 for replication. And that brings up the Hyper-V settings for host Hyper-V2. So this is the same thing as me going over to Hyper-V Manager, clicking on host Hyper-V2, going to the host Hyper-V settings, and then clicking on the replication configuration section. This just brings it up automatically for us through the wizard. So the most obvious thing we need to do here is to go up here and check enable this computer as a replica server. That's going to allow this computer to receive virtual machine replications. And there's really two things in here we need to specify. First, the authentication. Are we going to use Kerberos HTTP authentication where the data is sent over the network in an unencrypted form, or are we going to use certificate-based authentication with HTTPS so that the data is sent over the network in an encrypted form? Or we can actually use both if we want to, saying that we will allow either one of these types of authentication. I'll uncheck the certificate-based because we're just on a local area network in a lab environment. But more security-conscious companies will probably opt for the certificate-based authentication. Scrolling on down, the second thing we need to configure here is the authorization and storage. So which Hyper-V host will be allowed to send this Hyper-V host replicated virtual machines, and where will they be stored? Now, by default here, you could just say that you'll allow replicated virtual machines from any authenticated server, and that you want to put them in the default location for storing virtual machine hard drives. But the more security conscious would use the option here to allow replication from specified or particular servers by clicking Add here. Here we can specify the name of the host that will be sending us replicated virtual machines. By the way, it needs to be the fully qualified domain name. If it is not, it won't work. We can also specify a new destination if we want just for this host. For example, I could create a folder here called Hyper-V1 Replicated Virtual Machines and store the virtual machines from that host in that folder. That way you could very easily go into the different folders for the different hosts and see which hosts have sent you virtual machines and how much space those replicated virtual machines are using up on the destination host. Finally, we need to specify a trust group, which is really an identifier or a tag that's placed on the virtual machines when they're received so that they can only be run on Hyper-V hosts that are in that trust group. In my case, I'll just use wiredbraincoffee.com. I'll press enter here, and now we've added a entry here saying that only host Hyper-V1 can replicate to host Hyper-V2. That virtual machine sent from host Hyper-V1 will be placed in a specific folder, and that they'll be part of a trust group so that they can only be run on Hyper-V hosts that are part of that replication trust group. So now I can click OK here, and it gives us a special note that we need to ensure that host Hyper-V 2 has an opening in the firewall for this replication traffic. So either you drop the firewall, which of course isn't recommended, or you make an exception in the firewall to allow TCP port 80, and there's already a default Windows firewall rule there called Hyper-V Replica HTTP Listener TCP in. So in just a minute, I'll show you how to go over to that host and we'll enable that rule. I'll say OK here, and we're back at the Enable Replication wizard. I'll click Next. Now we're specifying where we will send this virtual machine, again to host Hyper-V 2 using port 80. We'll use HTTP authentication, and we will compress the data that's being transmitted over the network to try to use as little of your network bandwidth as possible. I'll click Next here. And now we're asked to choose which virtual hard drives from this virtual machine will be replicated. While many virtual machines will just have one hard drive, there are cases where you could have multiple. In this case, I do have multiple. I know that I've created a disk 2 on that virtual machine that's just a scratch drive. I really don't need it replicated, so I can uncheck it and again save some network bandwidth. I'll click Next here. And now we need to specify how much history we want created for this virtual machine on the destination. So we could say by default just to save the last recovery point or the latest recovery point of that virtual machine. But if we want a history, we could go down here and we can say that we want to save more than just one recovery point. We want multiple recovery points available of that virtual machine. So by default, it says we're creating 4 additional recovery points. They're created every hour, and that'll use an additional 3.4 gigabytes. If I increase this number here, you can see as I increase it, the amount of disk space used really goes up there. So now with 12 recovery points, I'm using 10 gigs of disk space. Now in my case, I think I'd just like to have 2 recovery points that'll use an extra 1.7 gigabytes. Something else of note here is that you can choose to enable incremental volume shadow services copies at a set interval. So volume shadow services can be enabled with your snapshots to ensure that the snapshots are application aware. So the applications such as SQL, SharePoint, Windows File Services, or Exchange, all those applications will be paused when the snapshot is taken. There could be some application performance degradation during that time, but the snapshots and the replications that are taken will be application aware, such that the application database has integrity. That means that you'll be able to recover those virtual machines, operating system, and application with no loss of application data. That sounds like a nice feature to me, especially if I'm running any of those, tier 1 applications. So I'll go ahead and leave that checked. I'll click Finish here. And now I need to specify the initial replication method. So how will I get the initial copy of the virtual machine to this other Hyper-V host? I could send the initial copy over the network, over the LAN or WAN. Of course, it tells us here that the initial copy is 8.6 gigabytes. So over a wide area network, keep that in mind. It could take some time to transmit that initial 8.6 gigabyte file. Now, once it's replicated, the initial replication is done, just the changes will be sent after that, which will take much less network bandwidth. But that initial replication could take some time. So we've got a couple alternatives here. The first alternative is to send the initial replication using external media. So here I could browse and I could specify, let's say, an external USB drive that's connected to this physical server, host Hyper-V 1. I could send the initial virtual machine replication to that, then bring it over to the physical server, host Hyper-V 2, at, let's say, the other data center. Or if it's across the country, I could ship it overnight to the other data center. They could plug it in, and I could bring it up over at the alternate site to save me from having to transmit this large 8.6 gigabyte file. The third option is to use an existing virtual machine on the Replica server as the initial copy. So in this case, I'm replicating a Windows 2012 virtual machine. If I already had a Windows 2012 virtual machine at the other site, I could say, I just want to specify that as my initial copy. And yes, there's going to be some fairly significant changes between my Windows 2012 server here and that Windows 2012 server, but nothing like having to transmit an entire 8.6 gigabyte virtual machine file. However, since I'm on a local area network, these two servers are together, connected with a gig Ethernet switch. it's not going to take that long, in my lab environment at least, to perform that initial replication over the network. I do want to start the initial replication immediately. Down here I could specify a date and time to start that initial replication, but let's go ahead and do it immediately so you can see the results. I'll click Next here. And now we get to review what we're about to do. We're about to replicate virtual machine Windows 2012-1 running on host Hyper-V 1 to host Hyper-V 2 using TCP port 80. We will compress the data and use Kerberos authentication. It'll go to this folder that we specified. We'll store 2 additional recovery points. We will use application consistent snapshots and send the replication of those every 4 hours. We'll perform the initial replication using the network and start it immediately. Let's click Finish here. It says it's enabling replication. And we've got a problem here. Let's look at the details. It said it cannot connect to the replica server. The operation timed out on TCP port 80. Well, why is that? If you recall back, I talked about I was going to go check the firewall and open up the port for that TCP traffic on host Hyper-V 2, but I failed to do that. So that's why the initial replication failed. Just a lesson, something you want to make sure that you don't forget to do. So now let's go over to that host, Hyper-V 2. And here on host Hyper-V 2, I'll go down to the network interface, open the Network and Sharing Center, go into the Windows Firewall. We can see that the firewall currently is turned on for the domain. Let's go into the Advanced Settings. I'll click on the Inbound Rules and scroll down to the H's, because right here is the rule I need. Hyper-V Replica HTTP Listener TCP in. Notice right now it's set to Enabled No. So all we have to do is select the rule and click Enable Rule. Now the rule is enabled. It says Enabled Yes. And let's go back to host Hyper-V 1 and attempt our replication again. Now let's close out the error, and we'll click Finish again, and it will again attempt to replicate this virtual machine. And there we go. This time we get replication enabled successfully. It says a replica virtual machine named Win 2012-1 was successfully created on the specified replica server Hyper-V 2. It says the network adapters for the replica virtual machine are not connected to any network. You can manually configure the network adapter settings for the replica virtual machine here by clicking on Settings. So inside the settings for this virtual machine on host Hyper-V 2, notice it says host Hyper-V 2 there. If we expand out the network adapter, again, this is the replicated virtual machine, not the original virtual machine. If we go down to failover TCP/IP, here, this is where we can configure alternate IP addresses for the virtual machine once it's replicated on the other side. Now, in my case, both of my Hyper-V hosts are on the same local area network, but that's not going to be the case for companies that have 2 different data centers and they're replicating virtual machines across a wide area network. You're going to have 2 different IP networks there, so to bring up this virtual machine at the alternate data center, you're going to have to specify new IP addressing for the virtual machine. So that's something you can do in here. You can also go into Test Failover, and you can say, okay, when I test failover of this virtual machine, which virtual switch do I want the virtual machine connected to? I'm sure you'll want to bring it up on that private virtual switch so that it's not connected to the production network, so that you can ensure that the virtual machine works just as well as the original virtual machine did. So I'll click Cancel here. And if we look at this virtual machine now, let's see what it's doing. If I scroll over to the right, notice the status. It says it's sending the initial replica and it's 40% complete. Notice also that there's a snapshot that was taken down here of the virtual machine. That's being used to send that initial replica. If we look at the replication tab for the virtual machine, notice it says that the host that this virtual machine is running on is the primary host. The replication status is that the initial replication is in progress. Replication health is normal. The current primary server is host Hyper-V 1. Current replica server is host Hyper-V 2. And so far, it hasn't been synchronized. That's because we're still doing the initial replication. So if we go over to host Hyper-V 2, Notice that there's a new virtual machine created here. This host didn't have any virtual machines a few minutes ago. Now we've got a new virtual machine with the same name as our primary virtual machine that we configured virtual machine replication on. And down here, we've got a replication tab. It says that the replication type for this virtual machine is that this is the Replica virtual machine. The status is that it's pending the initial replication. The primary server is host Hyper-V 1. Replica server is host Hyper-V 2. If we were to right-click on this and go down to the replication section, we've got some new options here. We could import the initial replica if we chose to do the offline replication. We could pause replication if, let's say, we were using too much network bandwidth, perhaps. We could view the replication health, and we can remove the replication. Let's go ahead and check on the replication health. And this is where you would go to get information about the replication status for this virtual machine. Things like how often is a replication occurring, the size of the replication, the latency, the errors that have been encountered, and when the last synchronization was. Also information about testing failover, the last time it was tested, and the status of any failover tests that you're currently running. So right now, the initial replication is still occurring. That's going to take some time. In fact, we can close this out, go back to host Hyper-V 1. It says we're 98% completed with the initial replica. This will take a few more minutes, so I'm going to pause the recording and be right back. Back here on host Hyper-V 1, if we check our status, we can see that the replication seeding has completed. And if we check the replication tab down here, it looks like our replication health is normal. Replication state is replication enabled, and we were last synchronized, let's see, just a little bit ago. So we've got replication all configured here. If we go to host Hyper-V 2, again, we see that the replication health here is normal. We can right-click on the virtual machine. I'll go to replication and go down to view replication health. From here, I can see everything looks good, everything's normal. We've had 27 successful replication cycles with 100% completed, 0 errors. We've got the average latency there, the maximum size, the average size. We were last synchronized less than 5 minutes ago. Currently, we're not running any failover tests. Now let's go ahead and run some failover tests. If I right-click on the virtual machine here on the replica host and go down to replication, it's here that I can initiate failover or test failover. Over on the primary host, host Hyper-V 1, I've got some different options here. I can go to replication, and here I can do a planned failover. So if I knew that something was going to happen to this host, I'm going to have to take it down. I can initiate a planned failover of this virtual machine. And what it will do is run through this wizard and actually ensure that replication is complete, bring down the virtual machine on the primary host, and bring it up on the failover host. All I have to do to initiate that here is click failover. So from here, there's some additional things you could do on your own. You could try that planned failover, you could test failover, and you can follow up on the replication health periodically to ensure that everything is running well. At this point, we've successfully configured, enabled, and monitored Hyper-V replication, an exciting new feature in Windows Server 2012. So with that, let's go back to our slides. And that brings us to the conclusion for this lesson. Thanks for watching using Windows Server 2012 Hyper-V Replica.